Hello, year 9. Hopefully you can hear me, otherwise I'm going to have to do this whole video again. But linear simultaneous equation substitution. Now, this is probably one of the trickiest things that you're going to learn this year, so it's going to be much harder having to do it from home. And I do hope that if you do have troubles, you let me know, and I can try and make some more resources or materials that will go through this. So linear simultaneous equations is all about solving two equations at once, okay? So what we're going to do is we're going to start off with a little scenario, okay? Looking at the equation, x minus 2y is equal to 5. There is the possibility of being more than one solution, okay? So x is equal to 5 and y is equal to 0 is one of these solutions, because if we substitute x is equal to 5 minus 2 lots of 0, that is just equal to 5 anyway, because 5 minus 0 is equal to 5. Okay, and so I believe that's what the next thing says. Okay, so if I do that, I can actually get, a solution that makes this true. But that's not the only number that works, okay? So that makes the equation true. Another one is when x is equal to 7 and y is equal to 1. So if I put 7 into here minus 2 lots of 1, so 2 times 1 is just 2, so I can change that to 2. That is also equal to 5, okay? I can also try 9 and 2. So if I put 9 minus 2 lots of 2, which is just 4, and that's also equal to 5. So basically what I'm trying to say is there's all of these different solutions that work for this. Now I want you to see if you can come up with any others. And I actually pause the video and do this because I want you to see that even though there are infinitely many, there's going to be one special one that we're going to be using in just a little bit. So let's take a second equation. Now the equation is y is equal to x minus 8. So are any of the solutions you came up with for the first equation work for the second one? So were any of the numbers that you came up with for that first one we did on the other side, so hopefully you made a little list, are they the same as this one here? So there are many solutions that will satisfy this equation as well, but only one of them. So there is only one answer which works for both. So if you got x is equal to 11 and y is equal to 3, that should have worked for both of the equations. So we can put it into this one. So 3 should be equal to 11 minus 8. So 11 minus 8 is equal to 3. So that is true as well. So if we go back to the last one and use 11 and 3, we should see that that one also works. So 11 minus 2 lots of 3, which is equal to 6. So 11 minus 6 is also equal to 5. So see how that one works for both of the equations? Okay? So you can get an answer like that, by just trying different numbers and seeing if they work for both of them. However, there is a method that we can use to actually work out what that answer is. And we call this solving simultaneous equations, or solving equations simultaneously. And the specific method that we're going to be looking at today, because there's not only one way to do these, but the specific method that we're going to be looking at today is the substitution method. So we're going to start with question 4 today, and we're only going to do 4 to 6, and yeah, I think that's all I've got for you today. But I've got a bunch of examples to show you how to do them, okay? So find the simultaneous solution for the following equation. So we've got x plus y is equal to 21 and y is equal to 2x. Now the whole idea of this is we're going to effectively put one of the equations into the other one by substitution. So if you look at this one, we've got y is equal to 2x, and we've got x plus y is equal to 21. Now, the first thing you want to look for is, do I have an equation, EQN is just an equation, that says y is equal to a bunch of stuff? Okay, so that's the first thing that you need to look for. And the answer to that one is yes, I do. So this second equation is y is equal to a bunch of stuff. In this case, it's not much of a bunch, but it's equal to 2x. So what we're going to do is we're going to use that as our substitution. So what we're going to do is, in our first equation here, so x plus y is equal to 21, wherever I see a y, I'm going to replace it with 2x, because y is also equal to 2x. So wherever I see a y in this first equation, I'm going to replace it with a 2x. So this is just going to make this other equation become x plus 2x is equal to 21. And I'm going to put that in brackets just to remind us that that was from the other equation. Okay, so substitute 2x in place of the y's in the first equation. Okay, so now we've done that, we can actually simplify this left-hand side and we'll get one of the values for x. So x plus 2x, well, that's just equal to 3x. So 3x is equal to 21. Now to get the x by itself, we're going to divide both sides by 3. And that leaves me with x is equal to 21 divided by 3, which is just 7. Okay, so that means that the x part for both of these equations is equal to 7. But we need to also work out what the y part is equal to. Okay, so we've got two ways that we can do this. We can now substitute this into the first equation or the second equation. Remember that we're trying to find what y is equal to. So we effectively ask ourselves, well, which equation looks easier to solve for y? Now, it doesn't matter which one you use, you'll get the same answer for both, because remember that this point is where both of the lines is true for x. But I'm going to use the equation y is equal to 2x, because it already says, well, y is equal to something. Okay? So let's substitute that point where x is equal to 7 into here. And we're going to get y is equal to 2 lots of 7. So y must be equal to 14. So therefore, my solution is when x is equal to 7 and y is equal to 14. And we can test that too by actually putting both of those numbers into the equation. It's above. So 7 plus 14 in the first one is equal to 21, and 14 is equal to 2 times 7. So that makes both of these equations true. Okay, find a simultaneous solution for the following equation. So again, we've got another equation that we're going to solve. And this time, what we're going to do is we're going to substitute in the bottom equation again into the first one. So because we're looking for when y is equal to something, okay, so where we have just one letter by itself is equal to a bunch of other stuff, we're going to use that equation and put it in place of the other one. So in this case, we've got y is equal to x minus 8, and I'm going to put it in replacement of that y. So I'm going to write out my equation again. 2y is equal to 5. Now you don't actually have to do this step, I just do it for me because I like it. Okay, now wherever I see a y, I'm replacing it with x minus 8, because remember y is equal to x minus 8. So wherever I see a y, so this is in this part here, so wherever there's a y, replace with x minus 8. So x minus, now 2 lots of, and then we need to make sure this is in brackets because we're timesing everything by this x minus 8, and that is equal to 5. So now what we need to do is we need to expand the brackets. So we get x minus 2x, okay, so minus 2 times x. So remember, minus 2 at the front, so minus 2 times x. And then minus 2 times negative 8, well, that's positive 16. So the minus 2 times the negative 8, which is positive 16. And that's equal to 5. Okay, x minus 2x is equal to negative x. So negative x plus 16 is equal to 5. That's just adding the x and the minus 2x together. Okay, negative x plus 16 is equal to 5. So removing the 16, I do minus 16 and minus 16. That leaves me with negative x is equal to 5 minus 16, which is negative 11. So if negative x is equal to negative 11, that must mean that x is equal to 11. Now, to solve for the value of y, what I'm going to do is I'm going to replace the value of, I'm going to replace it in either one of the two equations again. In this case, I'm going to replace it in the first one because it's already in the form y is equal to, and that's the value I'm trying to find. So y is equal to 11 minus 8, so y is equal to 3. And again, you can verify that that's true by substituting both of those values into either of the two equations, and you should get the same answer for both. Solve the pair of simultaneous by using substitution. So again, we're going to do the same thing. So I've got y is equal to 3 minus 2x, and I've got an equation that I can put it into. So rewriting 4x minus 2y is equal to 10. gives me 4x minus 2 lots of 3 minus 2x, which is equal to 10. Okay, so by replacing the y in this equation here with 3 minus 2x, okay, and I'm going to put it in brackets because remember I'm going to be multiplying -2 by everything in here. Okay, so it's going to give me 4x on the outside, minus 2 times 3 is minus 6, minus 2 times -2 is plus 4x, and that's equal to 10. Okay, continuing on, 4x plus 4x is equal to 8x minus 6, which is equal to 10. Now to remove the 6 from both, or to remove the 6, I'm going to add it to both sides, so plus 6 and plus 6. That leaves me with 8x is equal to 16. So then to remove the 8, we're going to divide both sides by 2. So that gives me x is equal to 2. Now to find my value for y, I'm going to substitute it into either of the equations again. Okay, so I'm going to use this bottom one again because it's already in the form y is equal to. Okay, so it's going to tell me what y is straight away. In fact, I'll tell you what, let's use the other equation and just to show you that it does work no matter which one you put it into. Okay, so I want you guys to put it in the bottom one, but I'm going to show you what it looks like in the second one. So I'm going to write that out. 4x minus 2y is equal to 10. Okay, so I'm going to replace the x with 2, so it's 4 lots of 2 minus 2y is equal to 10. So that's 8 minus 2y is equal to 10. Now to remove the 8, I'm going to subtract 8 from both sides, and what that's going to give me is minus 2y is equal to 2. Okay, then dividing both sides by -2, divide by -2, that gives me y is equal to -1. Okay, and so that would have worked no matter which value I put that in. So if I put it in the other one too, y is equal to 3 minus 2x. Well, 2 times 2 is 4, so 3 minus 4 is also -1. Okay, so it doesn't matter which one you do. Now, the last example that we're going to do before we're done. So the pair, again, it's the same thing. So what we're going to do is we're going to take this equation and replace it wherever I see a y. So I'm going to start off with 3x plus 2y is equal to 12. So wherever I see a y, I'm going to replace it with 3x minus 3, okay? Because I'm substituting it in, I'm putting it in, I'm replacing the y with the p that it tells me to. Okay, so 3x plus this time, so we've got 2 on the outside, we've got 2 y's. So because y is equal to 3x minus 3, and I've got 2 of them, I'm going to write it like that, and that's equal to 12. Expanding out, I get 3x plus 6x minus 6 is equal to 12, which is the same as 9x minus 6 is equal to 12. Okay, adding 6 to both sides, so plus 6 and plus 6, 9x is equal to 18. Okay, then dividing both sides by 9, divide by 9, we get x is equal to 2. Okay, so that's my first value. Now I need to substitute it into one of the other two equations to work out whether or not, or what my value of y is. I'm going to pick the bottom one for my last one this time. Whoops, I'm going to pick the bottom one for my last one this time. Okay, just to make it nice and easy on myself. So y is equal to 3x minus 3. Okay, so 3x minus 3. So wherever I see a x, I'm replacing it with 2 from back down here. So y is equal to 3 lots of 2 minus 3. So y is equal to 6 minus 3. So y is equal to 3. Okay, with that being said, you guys are only doing question 4 to 6 today, so there's not a lot for you to do, but you need to make sure you're doing all of these because this is one of the trickiest things that you're actually going to be seeing this year. So with that being said, if you need any help, please let me know on the Google Classroom. Otherwise, take it easy.